This is a Friday Shoes production. Our lesson today is 1-7 in the book on page 57. The target is I can write algebraic equations from verbal sentences and problem situations. And before we can write an equation, we need to know what an equation is. And that is a mathematical sentence containing two expressions separated by an equal sign. An important skill in algebra is modeling situations using equations. Most times when people come to me and ask me for help on math outside of school, and they have a math question, it usually starts off in words, and then I have to translate those words into some kind of expression or equation to get that correct answer for them or what they were looking for. So we use these steps. What are they? Well, first of all, we describe in words. Use only most important words, and we describe what's happening in the situation. Then we're looking for something unknown. So we call that the variable. We assign a variable, typically a letter. Define a variable by assigning a variable to represent unknown quantity. Then the last is the equation. We translate the verbal model, the things we were talking about in 1 and 2, into an algebraic equation. Best way to see it is in action. So here's example number 1. Write an algebraic equation. Here it is. Eduardo had a score of negative 150 points in the first round of a game. His final score after 2 rounds was 75 points. Write an equation to find his second round score. Well, they've highlighted everything for you, all the important information. This is a skill, by the way, so it's something you have to work on to pull this information out of a sentence or a paragraph. So they've highlighted, okay, you have a first round score, you have to add it with the second round score, and then that was his final score. Well, we don't know his second round score, so we're going to make that our variable. And our variable is going to be S for second round score. Then literally, you plug the information in that you have. Well, you know the first round score, that's negative 150. You know what a plus sign looks like. Second round score is going to be S, because we just defined it in the second step there in variable. And then the was is going to be your equal sign, and that's what that typically is in math. And then final score, we knew that was 75. There is the equation that we were looking for. Again, this is a skill. You got to practice it. So let's take a look at the first example that you will check on your own. Pause the video, try it, and come on back and see how you did. All right, this one says write an equation to model each situation. The winning time of 27 seconds was 2 seconds shorter than Tina's. Well, we have some important information. Now, I like to do it just a little bit differently than the book, so I'll show you what I do. I put boxes around things that I know are important. So we got winning time of 27 seconds. We have the was. Then we have the 2 seconds shorter than Tina's. If we translate this correctly, we're looking for, obviously we don't know what Tina's score is, so we're going to give Tina a variable, or Tina's time a variable. We'll call that Tina's time. And then we'll pull this together by saying, well, literally translate it, sentence structure for the math's algebraic expression structure. So our blue is 27 seconds. Our was is our equals. And then how do we represent this? Well, again, the winning time of 27 seconds was 2 seconds shorter than Tina's, which means Tina's was more. So we have Tina's score, we take off 2, and then that will be equal to the 27 seconds. There's the equation they were looking for. Hopefully you had that as well. How about the second one? Again, pause, do it on your own in your notebook, come on back and see how you did. All right, a drop of 4 degrees Fahrenheit, which is actually a negative 4 degrees per hour for the last several hours resulted in a total temperature change of negative 24 degrees Fahrenheit. All right, so it looks like it's going down. Let me highlight some things here. It's dropping 4 degrees per hour for the last several hours, resulting in a total, I like the word total temperature change of negative 24 degrees Fahrenheit. All right, so if it's dropping negative 4 degrees per hour, We want to find out, and then it ends up at negative 24 degrees Fahrenheit. The typical question would be, well, how many hours is that? So let's give our hours, as that, I'm sorry, the hours will be our unknown. So we'll give that the variable. How many hours is that? H will be the number of hours to reach that negative 24 degrees Fahrenheit. All right, what we're going to learn here is that per hour typically will either mean multiplication or division. Now, in this case, we have negative 4 degrees. It's going down, dropping 4 degrees. So we'll have negative 4 per hour, means for every hour. We're going to multiply those together. That means 1 hour would be negative 4 degrees. Then in 2 hours, it would be negative 8 degrees. In 3 hours, it would be negative 12 degrees, going down like that. So we have negative 4 times H. And then we have our total, which will be in blue here, just so you can match it up. Our total will be negative 24 degrees. So we'll actually put that in as negative 24 degrees. And there is our equation. Here's a real-world example. It says for the average consumer, a hybrid SUV would cost $1,473 less per year in gas to drive than a regular SUV. Use the information at the left to write an equation that could be used to find the yearly gas cost for a regular SUV. You can see they've highlighted a lot of information for you here. And if you look over on the left, it says hybrid cars operate on a combination of gasoline and electricity. The electricity is generated by the brakes of a car and stored in a battery. The estimated gas cost for a hybrid SUV is $1,386 per year. And that's the information you're going to want to have. And notice how they've actually completed this for you. It says they take the gas cost for the hybrid SUV, and that is $1,473 less than the gas cost for a regular SUV. Now we're looking for the regular SUV's gas cost, so we label that with a G. And they literally just take the numbers, plug them in as they are given through the sentence. Now I do want to say this. Notice at the end here they have 1,386 equals G minus 1,473. Sometimes you're going to actually switch things around. You're not going to put them in the order that they are. Notice that the gas cost right here is actually second because you're actually subtracting there. Let's try one on our own here. Go ahead and pause and then see how you do and come on back. It says the change in attendance from last year's spring dance was negative 45 students. The attendance this year was 28 students. Write an equation that could be used to find the attendance last year. So the change in attendance from last year's spring dance was negative 45. So the change in the dance, I like change. Last year's spring dance was negative 45 students. Then we've got the attendance this year was 128 students. Attendance this year's was 128. I should put this in blue. Last year's, the change from last year is negative 45 students. All right. And then of course the last part, write an equation that could be used to find the attendance last year. Well, just that statement right there should give you the hint that that's going to be your variable. So we're using, we want to find attendance from last year. So L will be our variable. That's last year's attendance. That's what we're looking for. Last year. If you pull this together, you can say the change from last year was negative 45 students. Now, we don't know what last year's attendance was, but we know that we have to take off, we'll have to subtract off the 45 because it went down 45 from the first statement. And we know what that equaled. It equaled our 128. There is the equation you should have came up with. Again, this is a skill that you need to practice to get really good at. How about the third example? It says the number of pounds of insects a bat can eat in 2.5 times its own body weight. Ooh. said the number of pounds of insects a bat can eat is 2.5 times its own body weight. That seemed weird when I read it. Given B, a bat's body weight in pounds, which equation can be used to find P, the pounds of insects it can eat? Well, it can eat 2.5 times its own body weight. When you see those words, times, think times. And literally, let's read the phrase. It says the phrase 2.5 times its own body weight indicates multiplication. So you can eliminate B and C. Take a look at B and C. B and C both have addition. That's not multiplication, is it? Now, what is it? Is it going to be 2.5 times B is equal to P, or is it going to be 2.5 times P is equal to B? Well, in this case, it says the pounds of insects eaten is 2.5 times the body weight. So you want to take 2.5 times the B to equal the P. So that's why it's going to be D. They call that rhymed. How about you give it a shot? Last one. It says a state's number of electoral votes is 2 more than its number of representatives, meaning electoral votes is more than representatives by 2. Given R, a state's number of representatives, which equation can be used to find E, the state's number of electoral votes? Now remember, the votes, electoral votes is 2 more than its number of representatives. So if they give you the R, and they say that's the representatives, the electoral votes are 2 more than that. So the electoral votes are going to be 2 more than the representatives. Let's look at those equations. Which one of those looks like it might fit? So electoral votes, 2 more than, well, it looks like that might be H. Is that true? Can you rewrite this and say R plus 2 versus 2 plus R? Yes, you can. That's called the commutative property. We learned that earlier and quizzed on it, actually. So you've got the right answer if you got H. Don't forget, you could also watch this video if you need to get some more understanding, or you could read the examples in the book, or see the personal tutor videos. And as usual, this has been Friday Shoes Production.